Okay, this is 3-3, parallel conductor fields. The objective is to observe the interaction of flux lines around parallel conductors carrying current. Our equipment is once again our 30 amp power supply, which I have here. Okay, that's cord connected to the wall when we plug it in. Okay, and then we've got a parallel conductor. Now this is very similar to magnetizing wire. It will still showcase what's going on within this lab space. Okay, so the first circuit is, they show us that we've got current flowing from, sorry, I'll zoom in a little bit more here. We've got current flowing out of the negative terminal, down through the conductor, and then back. So we have current going in opposite directions in our conductors here. So in this case, using our left-hand rule for conductors, if this is my negative here, so my current is heading up on this side, so my flux is going clockwise, and then it's going down, it's been jumpered at the back end there, okay, and then coming back the opposite direction this way, so it's going there. So in this case, we're going to have current flowing counterclockwise, and this was clockwise. So we should see them repel apart, okay, and then yeah, so that's sort of what we're going to do. I'll pick the camera up here, we'll fire it up. We will shake iron filings on this stuff again, okay, but before we do that, what I wanted to do was I wanted to sort of show, just by powering it up, what happens with the compasses. So let's just plug this guy in, just to show that we actually are de-energized right now. And then once we energize, you can see the compass has moved, okay? And if I shift that guy around, you'll see that there is actually direction there. Same with this one here, there's direction there. So I'm gonna unplug, or I'm gonna pull those guys out of the way, okay? And then I'm going to grab my iron filings again, and I'm gonna give them a shake. Okay, so we can start to see very quickly that we have a flux field developed, and it's pushing apart, okay? Kind of tough to see there. Okay, but there is a compressed density in between here that's pushing our flux fields out. Otherwise, if they were joined together, it'd be one unified circle, okay? So that's opposing polarities, so that the flux lines cannot interact. They're not going to aid each other in this case. The only time that they're going to aid each other is when the current is going in the same direction, which is what we're going to do here in a moment. So I'm going to unplug this now. Okay, we're going to just shake this stuff up so that it goes back to the random situation that it was. You can see that we've gotten rid of a lot of our flux, okay, or all of our flux. I'm going to plop the camera down here, and I'm going to change my connections over. Okay, so the next step that they want us to do is they want us to run the conductors so that current is going in the same path. So if we're going to get current going in the same path, here we've got our negative coming here. Okay, so current is coming up here and then down on this side. Okay, so now what we're going to want to do is we're going to want to bring this jumper over to the other end and swap it with my positive. Okay, sorry, having a little bit of difficulty with this connection here. There, that's better. All right, so we're connected up now. So now I'll just sort of show you what I've done. Okay, so down here in the terminals, I've got this guy here is my negative. So my negative is going to that terminal there. Current's coming up this conductor, heading around the back side, down through here, and then before I had a jumper going from this point to that point, but now what I've done is I've taken my positive to this point and I've got the jumper heading back from that terminal over to here where the positive used to be. Sorry, I guess that's hard to see. Okay, so then current is still coming up this way and then returning to positive via that connection there. All right, so let's just check this out and see what happens here. So we power it up. So we're energized again. I'll zoom in on the flux a little bit here. And we should see some unification. Sorry, I'm really trying my best to get the camera to work. Oh, come on. So the flux field is completely different from what it was in the first case. You can start to see that it's all joining in one big circular pattern. Okay, so this would in turn then tell us that the conductors are being pulled together, not pushed apart. Okay. Tapping it, you'll see that that keeps coming. Remember before there was such a distinct issue in between here. In other words, they were opposing each other. Okay, but now it's almost creating like a little bit of a like a bicycle chain look or a figure eight in a way, but even though they're not technically crossing, but you can see it's coming around with a big circular pattern, so they join together. Okay. And that pretty much ends that lab. That's what they wanted us to do. So I'll just power this down and I'll show you that just by tapping it, we return back to normal state. Okay? So that was lab 3-3, parallel conductor fields.